Hi, I'm John LaChance, and in today's episode of Hot Topics, I'm going to be talking about steam-enhanced extraction. We're going to dive into how this technology works, how it's applied, and how it's similar and at the same time very different from electric resistance heating and thermal conduction heating.
What are you going to pick? Hot Topics!
So how do we do steam-enhanced extraction? Well, we need steam. I mean, that's obviously a part of the name. So we are going to be talking about steam and using steam in the subsurface. But it's a little more complicated than that. So when we are using steam to remediate a site, the site has to be permeable. It has to be amenable for us to inject steam and inject steam in large enough quantities that we can effectively heat up in between the steam injection wells. So we put a network of steam injection wells in the subsurface. We design the screen intervals so that they're short, for one thing, which is different than a lot of other kinds of wells we put in the subsurface, but it may only be a couple feet long. The reason we do that is we want the steam to go in under a sufficient pressure based on the geologic conditions so that we get good uniform steam spread across the treatment zone. This allows us to use wider spacing. Steam injection wells can be spaced anywhere from 20 to 40 feet apart, and sometimes even larger depending on the depth and the geology we're dealing with. So that means a lot less drilling. That means we have less costs associated with that, and it means that we can put a lot of energy in the subsurface very quickly with these steam injection wells. Now, what happens when we add steam to the well? It doesn't immediately result in like blowing up a balloon, like the balloon expanding. Initially, as the steam goes in, it encounters a cold subsurface and condenses right around the well. And so the steam we're adding is actually converted to water pretty quickly. But that's okay, because that conversion or condensation results in the transfer of the energy from the steam to the soil and water matrix. But since we're adding fluid, we're adding water actively to these steam injection wells, we need a very robust network of groundwater extraction wells. And initially these wells will be pulling out ambient water, ambient temperature water, so it's kind of dull and boring. And eventually what happens is that the steam zone builds around the steam injection well, it'll push its way towards the network of multi-phase or groundwater extraction wells, and all of a sudden we'll start to see temperatures increase in the water at those multi-phase extraction wells. We wait a few more weeks and then we get steam breakthrough. Well, when this happens, this is the exciting time of a steam project, because what has been going on in the subsurface is this condensate front that's progressively moving out from the steam injection wells is pushing the contaminants and the steam condensate in front of it. And that will all arrive at your multi-phase extraction well over a fairly short period of time. And that's how we use steam injection to remediate a site. So we need a network of steam injection wells and a robust network of multi-phase extraction wells so we can extract vapors and the liquids to maintain hydraulic and pneumatic control at a site. Thank you. Thank you for watching today's episode of Hot Topics. Please check back in the future as we will be posting up additional episodes with new topics. And if you have a question or a specific topic or comment that you would like to share with me, I'd love to hear from you. My email address is jlachance@cascade-env.com. Thanks for watching.